to our channel Euclid Mathematics. Today I'm here with one of the topic from partial differential equation, which is a Green's function. So we are going to learn Green's function with some of the example from CSIR NET exam previous year question. So if you wanted to check more videos, you may check it into my playlist. Okay, now let's get started on today's question. I will explain to you all question first, and then we'll go for detailed understanding of solution. So here in our question, we have given the Green's function is given g of x zeta and 0 lesser equal x and zeta lesser equal 1 of the boundary value problem y double dash plus lambda y which is equal to 0 and the boundary condition y of 0 is equal to 0 and y of 1 which is equal to 0 given. So we have boundary value problem y double dash plus lambda y which is equal to 0 and the boundary condition also given y of 0 0 and y of 1 0. Then we have to check whether which one of the option is correct. So 4 options are given here. First, symmetric in x and zeta. Okay, so our first option says that Green's function symmetric in x and zeta. Second option says that Green's function continuous at x at which is equal to zeta. Third option says that dabba g by dabba x at x and zeta at x which is equal to zeta minus dabba g by dabba x at x zeta which is at x is equal to zeta plus which is equal to minus 1. So this one is the first, second or third option. Here it is the fourth option, x is equal to zeta minus x is equal to zeta plus which is equal to 1. So we have to figure it out which one of the option is correct. As we observe all our 4 options, it seems like that all are the properties of a Green's function. If you read this property properly, while you are studying Green's function, I don't think so. You can, nothing is difficult here. You can solve this question just an observation only. Okay. First property of a Green's function is that Green's function is always symmetric. Okay. So if you are going to solve this question using Green's function, you will get these options itself. But it is quite time taking. For solving Green's function, we have to check whether it is a trivial or not. Once you get the trivial solution, then after you have to say there as a Green's function exists and unique, and then you have to work for the values of a Green's function. So it is quite time taking process in our NET exam. So if you want the detailed solution using Green's function, I already uploaded videos on my channel. Okay, you may check these ones. Now here, first option, we make it correct because Green's function is always symmetric, the variable which is there. Okay, so we have x zeta here, that means g of x zeta which is equal to g of zeta x. It is always hold for Green's function. Okay, so Green's function is always symmetric. Green's function is always continuous at x which is equal to zeta. This is the second property. Second property of a Green's function, it says that Green's function which is always continuous at x which is equal to zeta. Now property number third, so here it is also third property. We have to check whether this differentiation which is equal to -1 or this differentiation which is equal to +1. So for this we have to apply one property, third property from Green's function. So whether it gives third or fourth. Now let's apply the property. I will explain to you all detailed solution for third and fourth. For checking our option number third and fourth, we have to check whether this property hold or not. Okay, so we have to check whether this property hold or not. So only third and fourth property, which is completely based on this third property. Okay, third and fourth option. So P naught of t, we get it from our boundary value problem, which is a y double dash plus lambda y which is equal to 0, which is given boundary value problem in our question. So P naught of t, which is the coefficient of y double dash. Okay, so here the coefficient of y double dash is 1. So L into y dash which is equal to 0. L is the coefficient of our boundary value problem. So coefficient of y double dash which is 1 here. So I got the P naught of t which is equal to, which gives P naught of t which is equal to 1. Okay, so put this value here. So we get the dabba g by dabba x at x which is equal to t plus minus dabba g by dabba x at x which is equal to t minus which is equal to minus 1 upon P naught of t which is a 1. So -1 upon 1. Okay, Now what we do, we multiply negative to all the sides, okay, because it's given in our options, that's why. So we'll get this term negative, this term positive, and this term positive. So take this positive term here, dabba g by dabba x at x, which is equal to t minus this term. Once multiplied negative sign, it gets positive. This positive term will be get negative dabba g by dabba x at x, which is equal to t plus that it terms become negative, okay, which is equal to minus 1 multiplied by minus 1, which remain 1, okay. Now let's check which one of the option is correct by using this property. So using this property, I converted this our green value for positive dabba and negative dabba here. Now compare this with our option third and fourth. Option third, it says that dabba g by dabba x at x is equal to zeta minus, okay, minus dabba g by dabba x is equal to zeta plus, okay, which is equal to positive 1, but it is given negative 1, okay. So it is negative 1 here and it is positive 1. So option number third discarded, okay, using this property. Now let's check for the option number fourth. Fourth option, it says that dabba g by dabba x at x zeta, which at x zeta minus, okay, it's true here, negative as it is, dabba g at x zeta by dabba x at x zeta plus, okay, x zeta. Instead of a zeta, I have taken t. Don't get confused. Just it's a replacement of variable, okay, and which is equal to 1. So our option number fourth, which matches to our given property that I explained over here. Okay, so it says that option first, second, and fourth, these three properties are true, and third, because of that negative sign, it got discarded. Okay, so third is discarded here, first, second, and fourth, which is a true. Okay, now for your complete understanding of the solution, you may check the following steps here that I already solved it in my solution. Okay, sometimes my solution here, which I'm explaining here, which doesn't match to my written solution here, because whenever I feel that I take some other counter example which is more easier to understand. Okay, so here it is the solution of my question. This is completely based on Green's function. Okay, so I hope you all have understood my today's solution. Nothing is difficult here, just we have to apply the properties from Green's function. So thank you everyone, thank you for my today's lecture.